Good. It looks like we've got quite a few people here already, so that's great. All right, hello everyone. Welcome to our webinar this afternoon. We're glad you could join us and take time out of your busy schedules. I'm going to start sharing my screen here, and we can begin our presentation.
Are you already sharing? I can see you.
I am sharing? Okay, that's
Yeah,
fine
you just
then.
need to make it
All right, we need to
full
go here.
screen.
There we go. So our topic is exploring Canadian research and EnviroPod's stormwater management solutions. And we have some very useful information to share with you. And we're going to split this presentation into two parts. I'm going to speak for a few minutes, and then Mike is going to talk to you a lot about the research that's been done here in Canada, which is quite specific to our industry. So my name is Barry, and I work with EnviroPod Canada. And of course, Mike is with EnviroPod as well. And he's one of our managing directors. So we look forward to his comments later on. Now, for those of you that may have attended an EnviroPod presentation in the past, you might hear some things that are repeated here this afternoon, but please understand that there's quite a few that have connected on our webinar that may be hearing this for the first time. So we're going to do just a mini review of a few points that we feel are important, and then we'll get into the meat and potatoes of the research that Mike wants to present. So for those of you who don't know, about 30 years ago, the LittaTrap was born out of a diving expedition that Mike and Greg went on, and they realized that the trash and plastic that they were seeing in the ocean was coming from urban stormwater. And they realized that if they could see it in their city, this was a worldwide problem. So they set about designing inlet filters, as you can see some prototypes in the photos here. And these inlet filters have been improved on many, many times over the last 30 years. We figure it's about 30 years of R&D. So we've come up with a product now that is called the LittaTrap that should last about 30 years in a catch basin. Now in Canada, our history doesn't go back 30 years, but only to about 2017, when the first traps were installed up in Richmond Hill. And they had a body of water, a pond that was anthropic. It wasn't getting enough oxygen because of all the leaf matter that was plugging up the catch basins and polluting the stormwater. So they decided to install some LittaTraps, and that solved their problem. They also discovered that they were capturing all kinds of trash. Now, in Canada, we've installed thousands of LittaTraps to date, all over the country, and we've won an award for Best Stormwater Innovation. And in California, where we sell a lot of LittaTraps, that is the only jurisdiction that has regulations around trash and stormwater, and it's illegal in California to have trash and stormwater. So you have to have full trash capture certification for your device and capture the right quantities of parts to be able to sell your device in California. And the LittaTrap does very well there. Now in Canada, we've also received the ETV verification for our EnviroBasin, which we'll talk about in just a moment. So EnviroPod has two products that we produce here for the Canadian market, the LittaTrap, which captures trash in a catch basin, and the EnviroBasin, which includes a LittaTrap, but also the ability to capture not only the trash, but now the sediment as well. Now the LittaTrap is a very simple device. You can see from the exploded parts list there, and the way it installs inside a catch basin with two anchor bolts to hold the bracket, and the seals that slip on top of the filter box. The basket drops in, very quick and easy to do, and it is very, very effective. So our devices are designed for mass production. We ship them in a flat pack, and we give them an 8-year warranty. So it's a well-known product and well-respected. But why do we need a LittaTrap? Well, this is the problem that is a worldwide problem. And if you look at a body of water, this is something you do not normally see unless you're inside the water as this diver is, because the plastic is being neutrally buoyant. It's typically found in the water column, not on the bottom, not floating on the surface, but in the water column. So it's a very insidious problem, and this is something that you can observe just about in any body of water in the world. So our LittaTrap is designed to address that at source in the catch basin and prevent all of this trash from going into the water bodies with the downstream stormwater. And the device has two modes of operation: normal, when it's capturing trash, and should the basket become full, then it will go into bypass mode. And you can see there is a bypass on all four sides at the top of the basket, about 2 inches high. So it will allow enough water that can come through the grate can pass through the bypass. It will not contribute to flooding or ponding if the basket should become full. Now we've developed a very modular, simple design for the LittaTrap. There are 3 sizes to the baskets, so we can fit all kinds of different applications, round, square, rectangular catch basins. And the seals, of course, are like the secret sauce that we have here, which enables us to fit the EnviroBasin in just about any catch basin. So we have half moon shapes for the round manholes and rectangular ones for the square and the round ones, the square ones. And of course, no municipality has the same infrastructure. Catch basins are different just about everywhere you go, province by province and state by state. So here are just some examples of solutions that we found. Now, we also, in addition to the trap, have found that there are other products that need to be captured in a catch basin, such as silt in the construction phase. So we developed a construction liner, which is made of a geotextile, which slips inside the basket and folds over, so the bypass will still work. And the liner is well supported by the basket mesh. So it's not something that's going to break, fail, fall apart, or be found in the bottom of the sump of the catch basin. We also have a microplastics liner, which is about 200 microns. They use this to capture some resins in industrial applications. And in some municipalities, they actually use it to capture sediment in the catch basin. It works very well for that. And as well, we have the nurdle liner, which is for capturing plastic pellets. And Mike will talk about those a little bit later on. So if you want to install a liner, such as the construction liner in a catch basin, you see the LittaTrap is installed. The liner, of course, sits inside. And now you will actually capture the silt in the catch basin in that basket. And it works much better than current solutions that are non-solutions. So we see the geotextile that's used just about everywhere, but it really doesn't work much. So the LittaTrap can be adapted or retrofit to about 99% of the catch basins out there, be they round, rectangular, or square. We have a solution, and you will find that you'll start capturing all kinds of plastic, such as these cigarette butts and other things as well, like leaves. And leaves, this is a big source of phosphorus pollution from our cities that contributes to phosphorus pollution downstream. And of course, the LittaTrap works well in the winter. There's no need to remove the baskets. They'll perform all winter as well. As long as water is running, the LittaTrap works very well inside the catch basin. There's a real quick video showing you how it's installed. It sits about 8 inches, 20 centimeters below the top of the grate. You drill 2 holes. Put in 2 anchor bolts to hold the bracket in place. And this video has been speeded up. It takes about 15 minutes, 20 minutes to do this installation. You cut the seals to length, and then they get screwed onto the filter box. And once this thing has been installed, at that point, it becomes a cohesive unit. All the parts are screwed together tight. All the water that would come into that catch basin is forced down through into the basket, and the basket fits snugly inside the filter box. And close the grate. That is how simple it is to install a LittaTrap. The maintenance is equally as easy or as simple. If you can lift the grate, you can lift out the basket. We suggest using a hooks, J-hooks, or a pick if you're lifting a heavy grate, but the basket is very easy to lift out and dump out, as you see being done here. Replace the basket and close the grate. We have a lot of LittaTraps, so we said thousands of them in Canada. This is just a short list of some of the municipalities, cities, and towns that have installed them, and this list is growing all the time. So if you don't see your town on there, give me a call and we can help you out. Now, the idea of a LittaTrap, you're not going to put one in every catch basin in every city. That's probably an unrealistic expectation. But we do suggest targeting hotspots. So we're talking about loading zones for truck and rail, pellet storage loading areas. That's a very key place. Loading docks are key places. We have some commercial users that use them at all their loading docks at their facilities across Canada. Waste storage areas. Think about recycling yards and places like that. Pubs and cafes where people congregate. You will always find trash. You will always find cigarette butts. Parks and recreation areas. After that ball game, the park can often be just littered with plastic cups and all kinds of trash that the fans have left behind. So you can't change human behavior, but you can target the hot spots and actually take some of this trash, prevent it from going into the stormwater. Now, cities like Barrie, Ontario, on Lake Simcoe were early adopters. About 5 years ago, we gave them one trap, and they were quite impressed. You can see what they were finding in the trap after it was installed. And they realized that their city was dumping a lot of plastic and a lot of trash into Lake Simcoe, and they're on a little bay on the lake. So the pollution load from the city was rather large. And so they decided to install 120 LittaTraps, represented by these blue dots in the downtown core. And if you've been there, it's a place where you find lots of streets, sidewalk cafes, and people tend to congregate. So there's a lot of trash. And this has worked very well. They're quite pleased. They pump these out with a Vector truck once every year in the month of May. So that is the LittaTrap. Let's talk just for a moment about the EnviroBasin, which is a step up. We know in Ontario, and most provinces have similar types of guidelines. They're talking about quantity control of stormwater. They don't want to exceed pre-development rates. They want to plan for the right storm events, and they want to keep the existing watershed boundaries and drainage patterns in place. So they try and control stormwater volume control and make sure that they've compensated where there is impervious surfaces. So infiltration, tree cells, and other LID things are very useful. And for major developments, they're looking at all kinds of volume controls. And the quality control, which is more where we come in with EnviroPod, it talks about removal of suspended solids. And just about everywhere you go, they want to remove 80% of the TSS. Some places are concerned about phosphorus, like the Lake Simcoe people. They've actually developed a tool to sort of measure that. And also there's other controls that are in place in certain areas for heavy metals, salt, oils. So in Ontario, this is coming through the CLI agreements with the municipalities, the consolidated linear infrastructure. But as we said, just about everywhere you go, you'll find some kind of a program where there are guidelines for stormwater management. So how do you get to TSS 80% removal? Well, wetlands and ponds have been a popular way for decades. Bioretention, tree cells, infiltration is a great way. We're seeing a lot of projects with infiltration. Sometimes you see sand filters. There are devices like jellyfish filters, which will remove more than 80% of the TSS from stormwater, as verified by ETV. But they're very expensive, and we'll talk about that in a minute. And oil and grit separators will also do part of the job, but they'll only be credited for 50% in Ontario, according to the TRCA in most municipalities. And so you need to look at a combination of these devices usually in order to achieve the 80% objective. And if you're using something like a jellyfish or something that's going to remove 80% of the TSS in one shot, well, by using pre-treatment for it in front of it, you will actually cut your maintenance costs in half. So what is the EnviroBasin? Well, basically, it is an at-source sediment and trash capture device. So we use a LittaTrap filter in the top, and then to the LittaTrap, we have some energy modifying components to capture and retain the sediment. And the device is pre-engineered and manufactured. It ships just the way it looks here in the photo, with the grate, the concrete structure, and all the components installed. And it was tested, just as you see here, to the Canadian ETV oil and grit separator protocol. So it is ETV verified and will remove greater than 60% of the TSS. So what you have here is an alternative to a conventional catch basin, where we're going to be able to collect and convey the water, but also treat it as well. Now, why would we need an EnviroBasin? Well, every every jurisdiction has some requirements or recommendations for infiltration systems. And if you don't remove the sediment and the trash for an infiltration system, it won't take long, and this is what it will look like inside your device. So that's why the TRCA and the City of Toronto recommend that 50% of the TSS removed, even if you're just putting the stormwater into infiltration systems. And it's also highly recommended by the MECP. So if you're also using detention, tree cells, and stormwater filters, again, pretreatment is the recommended procedure. And for standalone level 2 protection, say up to 60%, according to the guidelines for less sensitive water bodies or redevelopment of urban areas, moderate intensity land use, there are other ways to do. But pretreatment tends to be something that is highly important. So this is where EnviroBasin comes in, because you have here a catch basin with a LittaTrap, which is going to take out all that trash. We have a patented energy dissipator to absorb the velocity of the water and slow it down. We have a submerged outlet baffle and an extra deep sump. So all this means that we can reduce the flow velocities and capture the sediment in the sump. And this is really important because, as we can see from this video on the left, this is a catch basin with nothing inside, just water plunging in at 33 feet per second squared. There's a lot of force, a lot of energy. But when we look at the picture on the right, the video shows the LittaTrap with the energy absorbing device spreading the load over the surface of the sump. We don't have anywhere near the disturbance, the turbulence in the water, and now we can actually see the sediment particles settling out, and we're not going to resuspend what's already down in the sump. So the LittaTrap does all that with no moving parts, and it does a very good job. Now, maintenance of the EnviroBasin can be done by hand for the basket, as we've already seen, but more commonly, we're seeing this done with a Vector truck. And you can see here on the right, the video shows the Vector truck emptying out the basket. And the more trash, the more grit you have in the basket, the more grit and the more sediment will actually collect in the basket, not even in the sump. So you can see the Vector here taking it out. And then once you have that done, you can just remove the basket and you have full access to the sump. And now you can Vector out all of those heavy metals, the zinc from the tires that everybody's now talking about, and all of the phosphorus that's clinging to the particles down there, stuff that you do not want going downstream. You've captured it right at source in the sump. So a maintenance program for the EnviroBasin, as shown here, would be, say, once or twice a year, maybe more, depending on how much trash you were finding in the local environmental load. And on a cycle of 2 to 3 years, Vector out the sump. And this is all done from the surface. There's no confined space. So it's pretty simple. And you also have a lot of storage here, 320 liters of sediment you can store, 40 liters of trash. So if you compare a system that's designed entirely of EnviroBasins, you probably have more storage capacity than you would with an oil and grit separator. So if you go to our website, EnviroPod.com, you can find a copy of the verification statement for the ETV testing that we did. You'll see exactly what all the results were and how the tests were conducted. So that's there for everyone, a very open door policy on the certificate. This was the lab where it was done in Mississauga. And you can see it's an honest test because the particles are dispersed into the water just before it goes into the top of the catch basin here. So there's nothing left behind in pipes. It's all calculated in the measurements. And the graph on the left shows the blue line in the background, the specification for the test, with the overlays being the different particle size samples. And we can see that we met the spec very, very cleanly. So as far as sediment removal performance, we've said 60% and more. And here you see 60% and more on the very left-hand side of the graph. This is a low surface loading rate, agreed. Yet this is where most sediment comes into a catch basin. The 85th percentile coming in with that first flush of rain. So we're talking about small rainfall events bringing in most of the sediment. And the EnviroBasin is very efficient at that. And we're dealing with a very small capture area, maybe 1,000 meters or less for a standard EnviroBasin. So you can see that even as the surface loading rates increase, we're still able to capture sediment, but most of it's going to be captured at the lower end. Now, the other end of the test that's really important is resuspension, because there's lots of devices that will capture sediment, but the first big rainfall event that comes along washes it all out. So it really defeats the purpose. Whereas with the EnviroBasin, it passed this resuspension test with flying colors. The sump is filled in the test with a very fine flour material, and then the testing is done at all these different surface loading rates. To pass the test, you cannot exceed 20 milligrams per liter of effluent sediment concentration. But the bar graph shows that we're almost nil when it comes to resuspension. So it proves that what the EnviroBasin captures, it keeps in the sump. So we have our standard EnviroBasin, which is a 60 by 60 catch basin design and with the deep sump. We also have a design for a combination because some municipalities ask for curb inlet along with the grate. So we have a rectangular model here that works well for that, and we've made quite a few of those. We have a design for a manhole EnviroBasin and a ditch EnviroBasin that we have made quite a few of those as well for different applications. We have a twin, which seems to be quite popular. And we also have a junction EnviroBasin, and this is necessary. Either you use a junction EnviroBasin or another manhole, because you cannot have inlets and outlets down here in the treatment chamber, or you defeat the hydraulics behind the EnviroBasin. So you want to keep the treatment chamber just having inflows from the grate or perhaps some subsoil drains, but nothing else coming in the bottom. It's not designed to replace a manhole. Now, comparing an EnviroBasin to an oil and grit separator, there are a few differences. We'd just like to point them out quickly. EnviroBasin is a grade entry, and oil and grit separator is a pipe entry, so it comes from underground. Other than that, they both store sediment, have flow modifying components, and they're built in a concrete structure. The EnviroBasin will capture trash and sediment. There are very few oil and grit separators that really claim to capture trash. They're just really a sediment device. The catchment area for an EnviroBasin is small. If you have a twin, it could be as large as 2,000 square meters. Whereas an oil and grit separator, we're talking hectares, not square meters. So it's a whole different kettle of fish, downstream versus upstream. If we're talking TSS removal using ETV guidelines, EnviroBasin will get 50 to 60%, and so will an oil and grit separator. If we use historical particle sizes, which were typically larger than the ETV particle sizes in their testing, then EnviroBasin will get greater than 80% removal, as will an oil and grit separator. But the Canadian standard is moving towards the ETV, so it is a smaller particle and a little bit tougher test. The EnviroBasin will capture everything and keep it in the basket that's larger than 5 millimeters. And as we said, there's only one of 8 ETV verified devices in Canada that claim to capture 100% of the trash. And that's because they use a screen, and that requires, of course, a lot more maintenance. And oil is something that not all oil and grit separators remove, only 5 of the 8, and they will only retain oil. Whereas there are other hydrocarbons that still pass through, such as some fuels and solvents. We have a product called Lavasorb that will capture the oil as well as all the other hydrocarbons in the packet. And it's a device that sits inside the catch basin. So EnviroBasin is really an equivalent for sediment removal to an oil and grit separator. But because it's upstream, it gives you more options and a different way of looking at your stormwater management. So here's a diagram of an oil and grit separator. You can see from the ladder rungs, it's kind of a reminder that these things are sometimes very deep, large excavations. They also need this driving head. You have to back up the water in the pipe to make it spin, and that takes depth as well. sometimes up to 50 centimeters, plus or minus, depending on how big the size is. So all this means that you have a lot of digging if you want to put in an oil and grit separator. And if you have a high water table, or if you have a high rising lake level, or maybe some bedrock like we have in Eastern Ontario, out in the Maritimes, there's lots of bedrock, and of course in BC. So if you have to blast and do things like that, the EnviroBasin is a really good alternative because you're dealing with shallow excavation and you don't need the driving head, and there's no confined space requirements for doing the maintenance on an EnviroBasin. So by doing all this upstream at the catch basin, here's another set of benefits for a municipality or for an owner, whoever's going to install this. The LittaTrap basket by itself will capture 99% of the gross pollutants that come into the catch basin. And every municipality has a line item for budget cleaning out pipes, as you see here in the photos. And this is very common. If you have the basket and it's stopping all this, it's going to save you money for cleaning the pipes. So this is factual. If you're also taking out 60% of the TSS at the catch basin by using an EnviroBasin, well, then you're not going to see the sediment loading in your pipe system as well. And that means less maintenance down the road. So compare the cost of cleaning the catch basin every 2 or 3 years and dumping out the basket once or twice a year to the cost of unblocking a drain or detention tank. We think we have a really good solution here for managing stormwater. Infiltration systems really benefit from the pretreatment that the EnviroBasin offers. You will increase the lifespan of your system, and it will percolate for a lot longer if you're taking out the sediment at 60% and you're taking out all the trash. Older systems that are clogged with plastic and sediment, they need to be rebuilt and at great cost. So this is something that a lot of manufacturers of infiltration systems are really paying attention to, and we get a lot of attention from them. Again, here, tree cells. Why not give the tree its own catchment area so that it can get water whenever it rains, and water that's been pre-treated so it doesn't have the trash and the sediment that would clog up these sensitive root systems in the tree cells. We talked about jellyfish filters just a little while ago. This is what happens when they are not pre-treated. You can see how they clog up with sediment. And these cartridges are very expensive to clean or replace, and the cycle can be very short. So by using pre-treatment, by putting an EnviroBasin in front, taking out 60% of the TSS and all the trash, these devices, you will extend their lifespan, and the payback is very quick indeed. This is an example of a parking lot, and we should really start using photos for this because we're seeing a lot of projects that look just like this. On box store 1, we have an oil and grit separator with 4 catch basins and the roof water. On the right, we have 4 EnviroBasins, and the roof water is going straight through to the street. It doesn't need to be cleaned because there's no TSS in there. The EnviroBasins do a great job with the parking lot, and you can see there's a lot less infrastructure. It's a lot simpler to design and a lot less costly for the end user, the owner. So we're seeing a lot of projects that are built exactly like this. So to recap our discussion here about the EnviroBasin and the LittaTrap to some degree, we're talking about trash and sediment capture at source upstream. The device, the EnviroBasin, is ETV verified performance, and it will achieve the same as an oil and grit separator, the 50 to 60% TSS removal, but we're doing it at source. It has minimal hydraulic effect. Everything that needs to make it work happens inside this treatment chamber. As well, it is very easy to maintain. You can maintain the basket by hand or with a vector, and of course, pumping out the sump with a vector is rather easy as well. It is at source treatment, so there is less stormwater infrastructure in your project when using EnviroBasin. And it's ideal for all kinds of different low impact development projects. The whole thing has been designed, developed, and tested here in Canada. So we know it works in our harsh climate. And we have dozens and dozens of these devices installed all over the country, and they are performing very well. So that is the part that I wanted to present to you about our stormwater solutions. And now what we'd like to do is invite Mike to come and talk to us here about plastic pollution studies and stormwater pretreatment design and research update in 2024. And while Mike is setting up, I'll just tell you that if you have any questions, please use the chat box on your screen, and we will review those questions at the end of Mike's presentation. So we invite Mike to.
Hi Barry, can you see my screen?
Just a second. Yeah, I think so.
Yep, great.
Yep.
Thanks, Barry. That was a nice little introduction. Yeah, today I'm going to talk about some of the plastic pollution studies we've done with a range of partners and research institutions around Canada, and also some of the work we're doing at designing pre-treatment systems and how you integrate them into overall treatment train or a stormwater network. This research really covers the work with 22 and 23 because it takes a bit to write up. We also have a number of other studies currently going on with different research institutions or community groups. And so we'll be reporting that next year. So we really believe the way to better stormwater is actually through better science and better engineering. So that's what we're doing. So yeah, stopping plastic pollution through citizen science. As I said, we work with a number of different research institutions to kind of monitor and assess the amount of plastic pollution going through our stormwater drains. Now, this is really the reason we invented the LittaTrap. We are stormwater. EnviroPod's part of a company called Stormwater 360, which is a specialist stormwater company. And we really wanted to make a really easy and accessible solution to stop plastic pollution, because 80% of the plastic comes from the land and most of that is going through the stormwater drains. So we work with community groups, schools, universities, and what we do is we put litter traps in different locations, and we monitor them and count how much pieces of plastic, the types of plastic that we're catching them in them. And we can use this to lobby government and make policy pieces. And it also, as I said, we wanted to make the litter trap accessible, not that we're into child labour, but we really show that if children can maintain a litter trap, anyone can. And that's the other side of the research work we're doing. So just run through some of the studies we're doing. Had a great study out there in Newfoundland, in St. John's, in the downtown area, a beautiful part of the world. And we worked actually with Fisheries and Oceans Canada as well, because obviously they're a stakeholder when it comes to plastic pollution in the water. And they really don't want all our marine life full of plastic. So it was just a short study, 2 months over summer, and they put in 38 litter traps in their downtown area, in the touristy area, and they caught 5,000 pieces of plastic in 2 months from 38 drains. Now, most of that was cigarette butts, and that is common everywhere we go. Cigarette butts are the #1 piece of plastic pollution we find in a litter trap. And you're probably thinking, well, is a cigarette butt plastic? Well, the actual filter is made out of fine plastic fibers. Really good to be breathing in. But yeah, so that when it gets in the waterway, breaks down and turns into fragmented microplastics. So 5,000 pieces over 2 months was quite impressive. And most of that was outside restaurants, bars, and cafes. Ever since they banned smoking inside, we've found a lot more cigarette butts and litter traps. But hey, it's better than sitting in a smoky room. But yeah, so that was that study. We also have worked on thinking about waterfronts. Now, waterfronts are a good place to demonstrate this technology. A lot of people go down to the waterfronts, and then as we maintain it, we get a lot of questions. Oh, what are you doing? What's that? Oh, that drain goes straight into the harbour. So we're also working with the University of Toronto trash team. They're an organisation, a voluntary organisation as part of the University of Toronto. Where they're collecting a whole bunch of data on trash trapping technologies. Just again, like we intend trying to do, highlight how much pollution is going through the stormwater drains, how much plastic pollution, but also highlighting these solutions, showing that, yeah, it's actually not that hard to stop this plastic going into our environment. And they've been running this program now since 2019, the trash team. And they started with a product called Seabin. I'm not sure if you've seen it. It's a kind of powered bin that floats in the marina and it sucks the water through. In 2022, we joined the trash team and we put in some litter traps, 10 litter traps down in the Queen's Wharf area, down the bottom of town in Toronto as well. And we added some more. And then in 23, they've added in some automatic robot skimmers and some litter booms. And overall, the program over the last few years has caught 235 kg of plastic and debris that would have been floating around in Toronto Harbour. And that added up to 66,000 pieces of litter. Now, again, most of it, their biggest thing they're finding with this skimming and collecting things out in the harbour is foam, but closely follow the foam. I mean, like polystyrene, and that's a real problem because that is really hard to manage. It gets blown quite easily off construction sites, and there's packaging material and everything. So we find foam a lot, but closely followed by that was our good old friend cigarette butts. So this has been a great job, but if we want to focus down on the 10 litter traps that were installed down the waterfront, these were actually put in by the Toronto City Council Works Department, the guys that do most of the maintenance on the drains, and they found them very simple to install, and they've also been maintained by them as well. Now, they only do this work over summer. They were concerned about winter, about, they don't obviously get out as much. They were concerned if they block up in winter, they wouldn't be able to respond as quickly. So they did take them out over winter. Now, we did try to say to them, you don't need to take them out over winter. But if you're concerned, it's not really a bad idea, because in winter, when there's no real rainfall, you won't get runoff, so you won't get plastic pollution going through the drains. Big thing is that you get these litter traps in before the melt. Because when the snow melts or there will be a lot of trash and debris running out in the runoff. Over the last 3 years, we've got over 6,000 pieces of litter in 22. For 2023, it was a bit less. I think it didn't rain so much over that summer, so we caught less. And in 24, we're back up over 8,000 pieces of litter. Now, that's roughly about 600 pieces of litter per drain. And weirdly enough, we install these things all over the world now, and it's round about that for every one we put in an urban environment. We get higher in industrial sites, and I'll talk to you a bit more about that later. But it's around about 600 pieces of litter per drain. And if you think about how many drains is in your city or your town, the numbers are phenomenal. Again, it's just the usual suspects, cigarette butts, foams. But another thing I'd like to note, they did maintain them 4 times over the year. And for more research purposes, that's quite a good idea, because it takes quite a bit of time to sort through all the debris, to pick out all the bits of plastic. But they're only less than 10% full. So they really could have only been maintained once a year. Now, some of these other technologies in the study were really effective in collecting a lot of material floating around in the harbour, but the litter trap is more of a set and forget sort of thing. You don't need to actively do it all the time. It can sit for 6 months collecting litter. It's got the capacity to hold that amount of debris, 40 litres per basket in a standard one, and then you just maintain it when you want. We also have done another kind of study with another university, the University of Western Ontario, but this time we wanted to go a bit further than just macroplastics. We wanted to look at microplastics, or the researchers did, and And so a macroplastic is a piece of plastic that's over 5 millimeters in size. Now, they're the large, bulky things that will float around in the harbour. They're quite easy to see and pick up. They often do break down with UV and sun, and they turn into smaller and smaller pieces over time and can become microplastics. But a microplastic is anything under 5 millimeters. So what the University of Western Ontario did is they used the nurdle liner, or the 1 millimeter liner, on with the LittaTrap, and they just did 4 22-day monitoring periods where they put the traps in, each, and one in winter, one in fall, one in summer, one in spring. And then they monitored first they started with the 5 millimeter basket, the normal LittaTrap basket. And in the first 22 days, they got 222 macroplastic items and 75 microplastic items. Then they put the 1 millimeter liners on, and then they found they got, over the 88 days, they got 1,450 macroplastics and a massive jump in the microplastics. Obviously, it's a 1 millimeter liner, so you will catch everything over 1 millimeter in size. There was the usual variation and spatial variation. Again, outside very populated areas with restaurants and bars, there was more material. They did find that the 1 millimeter liner caught nearly 10 times more microplastics than the 5 millimeter liner. That's not really rocket science, but it was good to have it confirmed. And they didn't see any real issues with overflow or any maintenance issues, never caused any flooding. And that was one of the other kind of things they wanted to look at. You know, if we put a finer liner in there, is that become too much of a maintenance implication, or does it cause the system to clog? And this study proved that it didn't. So it's something to think about if we want to catch more plastics, especially microplastics. Now flowing on to another liner study, we've also again been working with the trash team and the University of Toronto with a program called Operation Sweep This Creek. Now, the University of Toronto has been working with the plastics industry in Canada and the Ministry of the Environment. Stage one, they did a bit of a investigation on the lakes and where they found plastic pellets, pre-production pellets. They're sometimes called nurdles. They're the little plastic beads that they use as feedstock to make new plastic items. Now, these are all manufactured at oil refineries usually, and then transported around the world by container ship or a train, but because they are about 2 millimeters in size and about the same density as water, they're very difficult to manage. So phase one was with the Ministry of the Environment, Ontario, and they monitored the seashore and looking at how much plastic pellets and how much fragments there were in the environment. Now, phase two, we worked with one plastics factory company and the University of Toronto and the plastics industry Canada, and we put in 5 LittaTraps in one site, and we monitored that site over 1 year, or actually only over a summer period, with the University of Toronto, and we caught 35,000 plastic pellets from 5 drains. As I said, that's a little bit more than you get in a normal urban area, where I said it was 600. We're really, the numbers are getting up. So phase 3, which was in 22 to 24, they wanted to see if we could expand it to a wider scale, and maybe what would that be, what contribution that would give to stopping these plastic pellets escaping. Now, they chose 5 companies, or reached out and found 5 companies, all on the drain to the Humber River, or drain to tributaries of the Humber River, which then comes down just, south of Toronto. Lovely park area. If you've ever been there, there is plastic pellets all over the seashore. So they went up to these 5 companies. One company actually produces plastic pellets, and 4 of the other companies were manufacturers of plastic products and using the pellets in their operation. 13 traps were installed and drains like this. You notice this one's in the loading zone. I should turn that off. In the loading zone, all the drains had to be cleaned first, and then we retrofitted these the litter traps. They caught quite a bit of material, and they caught it with a 1mm liner. We did start catching a lot more sediment as well. And we had to actually come up with a method of counting these, because you can imagine going through one of those one by one would take forever. And you had to somehow wash the sediment off these. It is quite hard to monitor a litter trap when it's sedimenty, because you get the sediment and all the pollutants mixing together. Not quite hard. It's doable. But it catches a lot. And so we developed a subsampling. The university developed a subsampling technique where we would just really count how much is in this bit and this piece and extrapolate it out over the whole lot. And over the 13 litter traps we installed in these 5 locations, in 1 year we caught 5.5 million plastic pellets. And that number is phenomenal. And this is only 13 litter traps, 5 sites. There are hundreds of plastic manufacturers in Ontario, let alone the world. And if in 5 of them with 13 drains, we're catching 5.5 million pellets, you can understand why we have a problem. Now, one site obviously was significantly a lot worse. It was clean except for the one drain, and that's LT13. LT13 was down the bottom of a hill, just on the boundary of the plastics facility. So this was the last place you could possibly have caught those pellets before they went off into the street and off into the environment. So that's where we caught 2.8 million of them. But as you can see, nearly every drain had thousands of pieces of thousands of pellets going through it. So really, they all needed treatment. Now, the university or management. Now, the University of Toronto has created a policy brief where we're circulating that with the federal government and the provincial government, and other parts in the world have regulated pellet capture. The plastics industry is doing a really good job trying to self-regulate and implement what they control measures. They actually branded that under a program called the Operation Clean Sweep. But there's a whole bunch of plastic factories that aren't a member of the Plastics Association, and they're not really doing anything. So there is a real call to try to regulate it. So that was some of the great work we've been doing, LittaTrap. This is really our effort to stop plastic pollution, and it's great to see lots of different organisations picking up the challenge, using our LittaTrap. And I really want to thank the University of Toronto, the University of Western, the CI, the plastics industry, for all that great work they're doing supporting us. Now, moving on to the EnviroBasin and pre-treatment. Now, Barry did a good introduction just previously on why pre-treatment is really important. We developed the EnviroBasin to support green infrastructure. We are big advocates of green infrastructure. The parent company to EnviroPod produces a lot of green infrastructure. And we realized early on that if you don't control the gross pollutants, you're going to have failing green infrastructure. So this is a bit of a discussion about some of the work we've been doing and design work we've been doing. So kind of kicked off quite a bit a while ago with the original LittaTrap, and also, and as Barry said, the LittaTrap is used in the EnviroBasin. And this project was one of the projects where we realized that if we combine the LittaTrap with some flow modifying components and a submerged outlet, we could get really high removal of sediment as well as gross pollutants. So the City of London commissioned AECOM on London as to have a monitoring study where they looked at not only the LittaTrap, but some couple of other catch basin inserts. Now, a catch basin insert is a technology that you insert into a catch basin that provides treatment. And so there's a number of different types on the market. They do different things. So they thought they'd have a little bit of a qualitative study on how much these things are capturing. So they installed them in the catch basins, and they measured sediment accumulation in in the devices over a period of time. So the findings they found was that the LittaTrap with a submerged outlet really enhanced the capture of sediment and debris in the sump, as well as capturing the larger gross pollutants in the basket. They found that the energy dissipation really helped reduce resuspension in the catch basin. Now, the maintenance staff, one of the project briefs was, do these things create more maintenance? And unfortunately, when you catch a lot more material, there's a lot more maintenance. Well, there's more maintenance. So there was, the maintenance staff of London were a little bit resistant. They're used to just coming along and cleaning out the drain with a vac truck and moving on, not having to lift out a basket or not having to clean out as much in the drain anyway. So they were a little bit resistant, but they did actually provide us with a lot of input, which we've brought on, such as, the baskets need to be easily vacuum cleaned, as you've seen, or you should use J hooks to lift them out rather than bending over and hurting your back. So we've adopted those. You've seen the video on vacuuming, and you can also buy J hooks, and we have a design if you want to make your own J hooks to lift them out. And here's some of the results. Now, the picture on the right is they had a control catch basin that did not have any catch basin insert in it. And this is the sediment accumulation in the device over time. Now you see it got up to about 80 centimeters in depth, and then it didn't accumulate anymore. That's because normal catch basins, as soon as they build up a certain amount of depth, that's actually quite high, they just start resuspending, like in the video, with no pre-treatment, no LittaTrap inside. So that's about as high as you'll get them, and they'll drop. Now, the other two performers didn't seem to accumulate. The bottom one didn't accumulate much, and this one was steadily growing up. Now, this is just a qualitative study. It's not, every catch basin can have a different sediment load, so we shouldn't really draw too much conclusions on this, but more look at the trends. So I'm not dissing my competition here. You can't really judge how much sediment is going into the drain. But the big performer in the study, though, was the LittaTrap. It instantly started collecting more material and kept on collecting more material further and kept on going up and up and up. Now, really, that trick was from the 2 stages of filtering. The sediment in the sump was down here below, but we also found a huge amount of sediment being collected in the basket, also mingled up with all those bits of plastic, leaf organic debris that ends up in the basket. So that was the Wonderland study. That kind of confirmed what we've been saying about EnviroBasin, but it was slightly a different form. So we actually, that's the same time we were developing EnviroBasin, and we used this as proof of concept to tweak the performance of the EnviroBasin for the ETV study. Now, when we have an oil and grit separator, we need to size it for the local regulations. You usually have to design the system to achieve at least 50% and treat 90% of the rainfall. Now, everyone has a different set of results for the ETV testing, or they might even have a set of results from their own testing or something else. Now, one of the issues we have in Ontario is that everyone seems to be designing with their own design spreadsheet, which is a little inconsistent. It's kind of opens to abuse because no one can really understand everyone else's spreadsheet. And so it leads to a whole bunch of different kind of results for the same thing. So the TRCA has developed a standardized sizing spreadsheet for oil and grit separators. They use the ETV results and use location-specific rainfall to estimate the efficiency of the oil and grit separator. Now, EnviroPod has taken that, and we've had lots of conversations with the TRC over various things, and we've modified it to handle an EnviroBasin. Unfortunately, the TRCA spreadsheet is all about a circular manhole oil and grit separator, not a rectangular square EnviroBasin, which is basically an oil and grit separator and a catch basin. And so we had to modify a bit of the spreadsheet. The spreadsheet's also good because it gives the rules for scaling. If you want to make your system bigger, so what are the requirements around that, and what would its flow rate be? And really, it really gives a consistent method of calculation. Now, I'm really hoping that the rest of Ontario, or even the rest of Canada, look at this approach by the TRCA and even adopt this, because it really can be applied anywhere throughout Canada, and it is really quite a robust piece of work. Now, the website at the bottom of this is where you can go to find that spreadsheet. Now, another thing we've seen is that we have a lot of different suppliers supplying their data with their own spreadsheet, but also using different particle size distributions. Now, the whole point of the ETV testing set approach was to standardize the testing. And they developed a particle size distribution that is more consistent with stormwater. What we see in stormwater is that we have a lot of fine sediment. Now, here is the ETV particle size distribution. And you can see that 50% is less than 75 micron. And in fact, 20% is less than 20 micron. That's not quite drawn right, but anyway. So it's very, very fine. And so what we have seen in the past, there was no clear definition of particle size. And generally in the past, it was coarser. And so when you designed an oil and grit separator in the past with a coarser particle size, you'd get 80% removal. Now we see a lot of suppliers using a coarser particle size distribution to prove 80% TSS removal, because that's what the regulations say. However, an oil and grit separator won't get 80% unless it has a bigger volume of storage where it can store the water up the pipe, or it's a very, very, very large system. And the reason I say this is that 20% of the particles are below 20 micron. And to get 80%, you've got to remove pretty much everything over 20 micron. And a 20 micron or even a sub 50 micron particle will take a very, very, very long time to settle. Probably not a long time. You will not have the time inside an oil and grit separator. But what our competitors, or what some people are doing, is they're just dropping the under 20 micron in their analysis. And that means it's a coarser particle, and then it's easy to get 80%. Now, we come across this a lot. The regulations say designed to ETV particle size distribution, but it might be an old approval. So we need to adapt our performance data to show what it would be with this coarser particle size distribution. Now, if you go to the ETV website, every product has its testing report, and in the testing report, they have removal efficiency by particle size fraction. And here they're the different particle size buckets on the left here. And across the top here is the surface loading rates. Now, this is the key function when we design an oil and grit separator. This is the flow of water over the surface area of the device. So that's the sump area or the manhole area in an OGS. And you can see here with the EnviroBasin, over the sub 500 micron particles, we're getting pretty much 100%. There is a little bit of wobble because it's testing and you get a bit of clumping of a sediment, but in general, as we go, we're 100%, we start to drop off as we get up to the higher flow rates here, the higher surface loading rates. Similarly, if we look down here at the 20 to 50 micron, we can catch a little bit at the start, but again, it really drops off quite quickly as we get up into the higher flow rate, higher surface loading rates. And you will see the same pattern with all oil and grit separators if you dive into their data. Oops. So with this table, we can convert our ETV results to any other particle size just for regulatory approval. Yeah. So one other thing I'd like to say is we've done quite a lot of this now, where we'll design a system with the ETV testing sediment and we'll get 60% removal. If we convert it to what some competitors call their fine PSD, which doesn't have under 20 micron, we find we get 80% removal. So it's something for young players. If you're checking designs and stuff, just check what particle size they're actually designing to. Now, similarly, we can use this PSD data that ETV provides us to consider how we would design a treatment train. Now, I'm sure you're all aware what a treatment train is. It's where we use different products, different treatment devices in a series to get higher removal rates and also to lower operation costs. Each stage in a treatment train really should target a different size particle. Either you should have a trash capture device at first, getting the over 5 millimeters. You should have a pre-treatment or a coarse or a grit separator as the second stage, which really captures stuff over 75 micron. And then you have a tertiary stage, which will capture the very fine particles and the dissolved contaminant. You can even add another stage there where you're discharging into the ground for water balance. So with that, you're not allowing that fine filter, which, like a rain garden or something, to be overwhelmed with all the trash and all the coarser grit. So this is how it lowers maintenance costs. Also, as you pass through each stage, it gives you an opportunity to remove more and more particles. So how do you calculate the total removal of a treatment train? Well, you can't really add up the percentage removals for each stage because these devices are usually tested by themselves, and that's how they get the percentage removal. You can't even try to factor up. You can't even take if the first device gets 50% and the second device gets 50%, you can't really say, well, that gets 50% of 50%, so that's 75%. Because what happens is that the coarser particle will be caught by the first stage and it won't be caught by the second stage because it's in the first stage. And that coarser particle is adding to their percentage removal that they claim. So to explain this a bit clearer, I've done a little case study. The case study will be 1 hectare site. We're going to use Toronto rainfall, and we've got 10 EnviroBasins, each treating 1,000 square meters, and we have one 1,800 diameter OGS. I'm not saying the names, but I've used data off the Canadian ETV website. The EnviroBasin by itself, the design would get 50% removal, and by itself, the 1,800 diameter OGS would get 54% removal. So let's see how this would work. So as I said, you've got particle sizes down the side here, and over 500 micron is 5% of the total load that's coming in. Now the EnviroBasin nearly gets 100% at that larger particle. So we remove 4.94% of that 5%. If we were to put the OGS first, we would probably remove 3.87% of that 5%. But the problem is that's both. If you put it second, all that coarser material has already been trapped by the EnviroBasin. So if you weight the removal of the over 500 micron, it's only really adding another 0.03%. So over 500, if we put a treatment train together, would remove nearly 5% of that over 500 bracket range. And as you can see, we can work through each particle size bucket or group to determine its efficiency. And as you can see too, it starts to really drop off as the finer particles together. So if we add them up, the first stage of the EnviroBasin would get 50%. And if we put in an OGS second, we can get an incrementally another 20% removal. We're not going to get 54% because we've already removed the coarse particles. So together they can combine to make 70% removal. And that's weighting in the different particle sizes. So this is a proposed method that actually encourages the use of treatment trains and gives it an incremental improved performance, which it achieves. Another thing we have seen a lot when we've tried to implement pre-treatment and EnviroBasins on sites over the last few years is the use of catch basin manholes. Now, catch basin manholes are a cost-effective measure for conveying pipe. They reduce the amount of infrastructure. And a catch basin manhole is where you have a manhole that connects underground pipes, but also has a grate on the top so you can have a grate entry. And they are daisy trained together like this in a site, but they're not actually very good hydraulically. They're cheap and they can be good for smaller catchments, But on larger catchments, as you get water coming in and water going out, water coming out through the device, and you get water falling in, you can imagine the turbulence and the resistance that has for allowing water to flow through the pipe network. Now, we've looked at this, and we've been asked to provide solutions quite a few times, but if you think about how the EnviroBasin works with all the treatment in the sump, well, we couldn't really stick an EnviroBasin in the bottom of here because water's flowing through it. So we've come up with a hanging EnviroBasin. I'm actually thinking about calling it EnviroBasin Air. And it's a stainless steel it's a painted steel EnviroBasin that can sit on an adapter plate under the frame, and we can drop this in to any catch basin manhole now and provide treatment. All the treatments, it's kind of like a steel catch basin that can sit within a manhole. And this will allow us to retrofit catch basin manholes without any extra infrastructure. Yeah, it is slightly smaller than the standard EnviroBasin. It's 550 by 550 in order to fit through. The device can be removed if you want to gain access to it, but again, it contains all the treatment zone in here. Oh, so yes, that was the quick update. I hope you didn't find it too many graphs and too many numbers, but yeah, open for some questions now.
Yeah, thanks, Mike. That was great. We have one question here so far. If anybody else wants to add one to the chat, we'd be happy to entertain that. But this one is from Sylvie, I think out in Vancouver, and she wants to know, do you have any data about percentage TSS removal with and without the trapping hood? I imagine all of the work is done by the LittaTrap and just wanted to know if you had data. So Mike, can you answer that for us?
Yeah, so we added, obviously, as I said, in London, we observed that capture in that did have a submerged outlet. Lots of catch basins already have a submerged outlet through the use of a GOS trap. There's also some other technologies that are just an outlet hood. We did find a roughly a 5% bump by putting the hood on over just using the LittaTrap, which is very beneficial when you're trying to size and design these things. But yeah, we also found that things like the sump depth and the geometry of the sump also had an influence. So that's why we made it a manufactured solution. That's why we put it in the catch basin. So we have that sump volume that we know can achieve that sort of TSS removal. Obviously, if you've got low budget and things like that, and you want to retrofit, you could just chuck a LittaTrap in there. But it is not as effective as the full EnviroBasin and it's not repeatable. It really depends on what we're putting it into. So I hope that answers. I've got a bit of a report, Sylvia, I can flip to you of lab testing. It's not to the full ETV protocol with just a LittaTrap, but it also included, it had leaves in it. We did some testing because these things do capture leaves, and those leaves also help the capture of sediment, but it's very hard to quantify and make repeatable. So we tested it without leaves as a conservative approach. But I can flick you that report over as well after this.
Thank you very much, Mike.
That answers the question. Yeah.
Thank you. So that seems to be the only question in the chat box today. So we would like to thank everybody for attending our presentation here and for reviewing with us EnviroPod's solutions for stormwater treatment, as well as some innovations in research and in the Canadian marketplace. So thank you very much, Mike. And
yeah, feel free to fire through any other questions that might come to you. We did talk a few about our design tool and the way we can adapt things too. We're happy to work with you on finding solutions and working in with your existing designs, or if you've realized that you don't think the pre-treatment's good enough, we can really work with you, because there's no real cookie cutter solutions to stormwater here. Every engineer needs to think through their restrictions and design a site appropriately. So cheers. We're ready to help.
Thanks, everybody. We'll look forward to talking to you soon.
See ya. Bye.